So this is the second video of trying to do some examples of Advent of code to warm up for the 2024. So I'm going to go here. I just finished doing day one. I'm going to go look at 2022 and start doing day two. So what we've got is a list that has two numbers separated by a dash, a letter followed by a colon, and then a string. And these are passwords, and you have to decide whether they are valid or not. And the rules says the lowest and highest number of times a given letter must appear for the password to be valid. So this A must appear at least once and no more than 3 times. And this here, the C must appear at least twice, but no more than 9 times. And it says that this in this little sample here, it's got 2 passwords that are valid. The middle one, C, D, E, F, G, is not because it contains no instances of B at all. And we need to have at least one instance. So the idea is you go through your list of passwords and count up how many are valid. So the first thing we need to do is we need to start up an Emacs. And we're going to do that like so. And we're going to open up a file. aoca 2020 aoca20.el. So I want a 0 in there. And I'm going to use my little aoca function, 2022, and I'm going to say insert the template. So similarly to the last time, what we need to do is we need to copy the sample input into one variable. Sorry, which is this part1 sample variable. And that's correct. Then we have to get our puzzle input, and that's down here. I'll put that here. That's correct. Then we have to go to the end of the expression and Control X, Control E to evaluate it. Similarly, this one we don't need to evaluate because we're not going to use it, at least so far that I know. This one we do have to evaluate to get the commonness compatibility, and this one we have to so we can debug. And then our job is to take the input string and turn it into something that we can use to count up how many passwords are valid. Now, one of the cool things about Emacs is it has regular expressions. So built in to Emacs and ELISP functions that allow you to do them pretty easily. So the idea is that we can say this is going to be a number followed by a dash, followed by another number, followed by a space, followed by a single letter, followed by a colon, followed by, it looks like one space, but we can say any number of spaces, and then the rest is a string. And we can easily do a control meta R, which is a regular expression search backwards, to check for that. So that we start at the beginning of a line. We're going to make a group and a number, and we can make it plus like that. So that's the first number, a dash. Now, in the middle of doing the search, we can say meta E to edit. So I can just copy this because we're going to use it again. Well, there's a keystroke so that was dash space. You can say plus in case there's more than one space. Or you can do this way of doing a space. dot. Oops, we need a group of the dot. That's the single character. And then colon, another space, followed by dot plus. Again, with a group around it. So while we were editing, it wasn't actually doing the incremental search, but as soon as we type Control R, we're now going to. So it says it's incomplete input. So we can go back to editing. Oh yes, we managed to not copy the backslash that needs to quote that. So let's try going back again. Okay, so now you can see that we are in fact matching the entire password strings. A cool trick to check quickly is you go and see that the whole page is highlighted, and then do a Control V and just do the search again. So you can page forward each time. To check a page worth at a time to make sure they all match the. You can do just Control S, but that just moves down a line. With auto repeat, it's not terribly fast. I mean, terribly slow, but anyway. So that regular expression is good. Now, because Emacs remembers the regular expression, we can do the regular expression search, say edit, and then just copy the whole thing, and now we have it available for us to do something with. So what we want is a loop with password info. What that's going to be is it's going to be a list of entries. So each entry is going to be made up of a line, information from a line. So we're going to say loop for line in split string of input string by a new line. That is getting us a somehow. All right, I need an end there. That's going to get us the line that has this string. Now, when you want to do a regular expression match in eLisp code, you have to take the regular expression and unfortunately the backslash is a quoting character inside the string. So we want to replace the string of backslash with 2 backslashes. So that means that stored inside the string where there's 2 backslashes, there's really only 1 backslash character. The function, so I can go Control Meta U to go up. The function is called for position, let's say, because the string match returns a position, equals string match of the regular expression and the string, which is the line, for the various different strings that we get, begin, end, character, string, password equals loop for I from 1 to 4, collect match string, no properties. This is which match, which parenthesized group you're getting. And 0 is the one that matches the entire regular expression. So you start with 1. But when you do it against strings instead of buffers, you have to actually pass in the line. And what you're getting back is indices. So, right, so that's that. But these will be strings. So beg, end, car, and password will be strings. So we need to collect a list of string to number of begin, string to number of end. And again, the char will be a string, so we just want to get the one character out of that string. And then we want password as a string. That's the only one we really want as a string. So password info is going to be a list of lists. Each list has 4 elements, 2 numbers, a character, and a string. And again, because it's the with clause, it's password info is going to be bound for the entire duration of the loop. So what we want to do is we want to loop for start and char password in password info for valid equals. The rules are that we need to have only as many characters, the instant occurrences of the character that are inclusively between the 2 numbers. So we want less than or equal to start, and then here we want to do loop for C across password. Cross is what you use as a loop iteration for vectors, and a string is just a vector of characters. Count equal C char. So if the character that we're going is the C, we're going to count it, otherwise not. So that's going to return the number of such characters in the string, and then end. Actually, better would be these. This is min max. Min max. Much clearer. So that's count valid, and we should be done. So I usually, most of the times, I will actually do this because that's the standard style, even though the template puts the closing parentheses hanging. So in the example case, remember they told us there were 2 valid ones. Did I not? Part 2. Did I not put it in the right place? So part 1 sample. Nil, okay. So let's see what's going on. First thing we want to do is we want to see if we can, unless position do debug. So if we didn't match anything, position would be nil. So let's try that. Control Med E, Control X, Control E. Wow, that's strange. Don't know why I typed something wrong. 2. Okay. So I didn't need to do any debugging. So that was the right thing. So now for our actual real life input, nil. So string to number begin. Did I for when I took out the debugging stuff, I didn't take all of it. This should have come out too. Look at that. There's a space in front. So let's try. Yep. How that space got there? It must have been me typing when I was doing the Control V stuff. We could have made the regular expression more robust to that. And this is a Lispism. When you do a def-var, if you reevaluate it, it doesn't actually change it if it already has a value. So we have to, I think, well, we can test that. So 469 is what we think. So I was wrong. When you do reevaluate it, it does redefine the def-var. In some Lisps, it doesn't do that. And in fact, I'm pretty sure that in older Emacs Lisp, it didn't. So the answer was 469. And so we now go on to part 2. The shopkeeper realizes that he accidentally explained the password rules from an old job. So this one, what it actually describes is just the numbers or 2 positions in the password, one based indexing. Exactly one of those positions must contain the given letter. Other occurrences of the letter are irrelevant for the purposes of policy enforcement. So A needs to exist in 1 or 3, but not both. B needs to exist in 1 or 3, but not both. So that one was valid. This one is invalid. C must exist in 2 or 9, but not both. And so it's invalid because it's in both. So we just have to change our password evaluation. So again, I'm going to copy this so we can compare later. Optional part 2. And so this is the only thing that changes if part 2, sorry, we need a different to be specified test. That's another cool thing. In Emacs Lisp, there's this debug statement. When you hit it, you go into the debugger. So you can put that there as a placeholder for something that you're going to write later. And if you happen to hit it, you will know. And you can in the debugger look at variables and single step and do all sorts of interesting stuff. So in this case, we still should get the same answers for these guys. I.e. we'll never hit the debug because it's conditionalized on part 2. And so for part 2, we need n hits n hits 0 if equal aref password min, except that there's 1 base, so and Emacs Lisp is 0 base, so it's 1 minus min. The char. Okay, we want to do it as when incf and hits. And now we want max. And the condition is equal 1 and hits. And so let us, oops, we have to define our control meta at is a cool thing. It highlights a whole expression. You can just do meta w. Now that was the part 2 call. Input string t. Another meta backslash deletes white space. So now we ought to be able to. This is on the sample data. Same problem as last time. We don't have a separate part 2 sample. So we only have one valid. That's what it said for the sample data. 267 is the answer. We think that's the right answer. And it is. So if we, another cool feature of Emacs, so I can do Control X2. Now I have 2 windows on the same buffer. So I can go up. On the bottom one, I'm going to go up to the second definition, the one that handles part 2. And on the top one, I'm going to go up to the first definition, the one that we started with. And there's medx compare windows, which moves forward in both buffers, in both windows. They don't have to be on the same buffer. They can be on anything, but it keeps moving forward as long as it's seeing the same thing. So here we added this optional argument, so I can just move past that and say medx compare windows again. And now again, we moved forward until we get to the if, where we added this extra. If we move down to here, and we do it again, we move forward until we get to the extra parentheses surrounding the if. But if we move forward past that, now we get to the end of the function. So this is a nice way of being able to see what's changed. Anyway, thanks for your attention.